Okay, let us discuss this problem. This is hydrolysis of ester in acidic medium. So you have to give me the product A and B, and one oxygen is labeled oxygen 18. This is not simple, oxygen 16. This is the oxygen 18. So you have to give me the A and B. The only important point you have, that is oxygen will go either in A or either it will go in B. That you have to tell me. Okay, if you have done fine, let us discuss. So hydrolysis of ester, and this gives you an acid plus an alcohol. Did you remember or not? So acid plus alcohol. So these are the two things you are going to get. So what you will do is, first step is acidification. If you remember, so I am acidifying this oxygen, and then it will have a positive formal charge, and you have oxygen, and let us call this is oxygen 18. Now next step, H2O will attack. So let me attack H2O. So if one molecule of H2O attacks on this carbon, this opens. So now I can write the same step. I am losing H plus also. Are you getting? So if I lose H plus, what I will have? So you can copy. So you will have CH3 COH, and here also you will have OH, and here you have O18, and then ET. Are you getting? Now what will be the next step? Next step will be, now this will go here, and this forces this oxygen to go out, because on one carbon 2 OH group is not stable. So you will have CH3 C double bond O OH plus this side will have ETO minus. Now this minus will take H plus from here, or since solution is acidic as 3O plus, so you can take H plus from water also, because the solution contains H plus as 3O plus. So finally you acidify this solution, so you will have CH3 C double bond O OH, so we will get one acid plus, and we will get ETO minus. Now this oxygen is 18, so this oxygen is again 18, so we will have ETOH. The only important point you have in this question is labeled oxygen will go go with alcohol. So this you can remember. So labeled oxygen will appear in alcohol. This, if you remember this, so fine. So easy to remember this small information. Now let us discuss this problem. This is an easy problem, you can do this one. So you have to give me the product. Yeah, this is a simple reaction. So this is Br2Fe, that is a bromination or halogenation of benzene ring. This group, nitrogen, so this is the activator group. So this is the activator, not so strong activator. If you remember, we discussed in the class, if we have NH2, now this group is very highly activated because this has a resonance effect. Similarly, if we have OCH3, this is again a strong activator because this can give lone pair to the ring. But if I make from this, if I make derivative of this, something like this, NH C double bond OCH3, now in this case, this lone pair can go this side as well as this side, both sides. So this will become less active. Similarly, in this case again, C double bond O if you have a phenol, I cannot make some derivative in this case. If you have a phenol, something like this, OH. So this phenol, I can again, in this case, I cannot make any derivative, so it will similarly remain OCH3. But in this case, if you have a phenol, I can again make derivative. So I will have O, and then I can have COCH3 group I can attach here. So this derivative in this case again, this lone pair can go this side as well as this side, both sides. So this decreases the reactivity. So if I want to decrease the reactivity of phenol, I have to prepare something like this. If I want to decrease the reactivity of aniline, that is in NH2, I have to make something like this. Now in this case, this is a slightly weak activator, of course, but still bit activator. So it will orient at ortho as well as para position. So you will have ortho plus para product. So let me write. So here you will have NH C double bond OCH3, and let us say one will be para, another productive, sorry, this is the bromination, so I have to add Br here, not CH3, and another product is ortho, NHCOCH3, and then you have to add ortho position a bromine group. Are you getting? Simple. So at ortho para product, so this is the ortho and this is the para product. So if you have copied, then I can discuss the next problem. So easy things. So we have discussed how we can decrease the reactivity of phenol and aniline by formation of derivative of phenol and by formation of derivative of aniline. So this is easy. Let us discuss the next problem.